Hello students, welcome to Saurabh's classes. In this video, I will be discussing about the ISS paper 2 syllabus topic wise, and in ISS paper 2 syllabus we have a lot about industrial statistics, econometrics and all. I will be discussing all of those with you now in a descriptive manner. So let's start with industrial statistics. Industrial statistics. So as per the syllabus, our first topic is process and product control. Process and product control. As you know from the name, it's very clear that process and product control are basically those processes which are basically needed for the quality control of the product statistically. So we can write that product control and process control both are method of statistical quality control. Now these two methods are basically applied to distinct phase of plant operation. These are applied to distinct the phase of plant operation. Now I am going to discuss process control in a more descriptive way, that is process control. Look, process control is actually a statistical quality control. I already told you about it. It's a statistical quality control. Now it's very important to focus on what it uses in industrial statistics and how this helps us in controlling the quality of the product. So process control is that method of statistical quality control in which the quality of the product is controlled while the products are in process of the production. So the quality of product in this case, the quality of product in this case is controlled when the products are in process of production. So what do we mean by this? This means that when you need a product in an industry, you will have to produce the product. When this production process of these products are going on, then the statistical quality control or the process control is actually helping us to maintain the quality of these products. Now there are many control charts which actually help us in this process control charts. We will be coming to the control charts later. Just know that the control charts actually helps us in process control. Now I will talk about product control. It is actually another method of statistical quality control. Now we'll again focus on what its purpose is and how it helps us. First, you need to know that in this statistical quality control, the quality of the product is controlled while the product is ready to dispatch or sell to the customer. So here the quality of product is controlled while it is ready to dispatch for the customer. Ready to So basically the main difference between this process control and product control is, in the process control, when the products are in the process of production, that is when they are being produced, then the quality of these products are controlled. But in product control, when the products are already produced and are ready to dispatch or sell, then the quality of this product will be controlled. Now this acceptance sampling is another thing which helps in this product control a lot. Now I'll be talking about producer risks, consumer risks. So what are the risks in the acceptance sampling? As acceptance sampling helps us a lot in product control, so we need to know about the risks. Risks of acceptance sampling. I will obviously be discussing these in a more descriptive way later in this discussion. So risk of acceptance sampling. I'll just name the risks. They are known as producer's risk and consumer risk. Consumer risk. Now we'll move to SPC. SPC is statistical process control. SPC is statistical process control. Now, what is statistical process control? As you see, we are using industrial statistics here. So of course statistical process control is a very important method, and it is that method which is used to control the quality of the product, which employs statistical methods to monitor or control a process. It is that method which includes statistical method to monitor or control a process. Monitor or control a process. Now, this actually helps us to ensure that the process operates efficiently. It also helps us to ensure that the process operates efficiently. Now, what is the basic need for this process being operated efficiently? There is a basic need. For the process to operate efficiently. So what is it? What is the need? Now look, when you are actually producing many products, then it is very important to know more specification about those conforming products with less waste. That is, like when you are producing products in an industry, then you will of course need more information, more specification about them, and also you will need less waste, because otherwise the industry will not be running very good. So you can say that this helps to get more specification conforming products also with less waste. And this is also known as this waste is also known as scrap. Now SPC can be applied to any process where the conforming product, that is the product meeting satisfaction. Conforming product is a sophisticated name of the products which meets the satisfaction of the customers. When the output of these conforming products can be measured, SPC can be applied in all those cases. So where SPC can be applied in any process where the output of conforming products can be measured. Now you need to know the easy term for conforming product, because otherwise you will be wondering what conforming products are. Conforming products, these are nothing but products that meet satisfaction of customers. Before I go to the next part, let me add a page here. Okay, so now what are the key tools that are used in SPC? Key tools of SPC. So the key tools of SPC are basic. I'll number them. They include run charts, also control charts, a focus on continuous improvement, and the design of experiment. So if I ask you about an example of using SPC, so where will you apply this SPC? An example process where this SPC is applied is manufacturing lines. Now there is also another very important and interesting thing about SPC. SPC is actually practiced or it is actually followed or practiced in two phases. Now there is this first phase which is called the initial establishment of the process, and there is another phase, that is the second phase, which is the regular production use of the process. Now in this second phase, that is regular production use of the products, a decision on the period to be examined must be made. A decision on the period to be examined must be made. Now this decision is actually depends on 5M and E condition. So you will actually be wondering what is 5M and E condition. I will be simplifying this term for you. 5M and E condition is nothing but man, machine, material, method, movement, and environment. The wear rate of parts used in manufacturing process and wear rates of parts that are used in manufacturing the process. Like for example, you can take machine parts, jigs, machine parts, jigs and fixtures. Now the advantage of SPC over quality control is a well known fact of industrial statistics. Advantage of SPC over other methods of quality control. Other methods such as inspection, so now I'll be telling you about the advantage. The advantage is that SPC emphasizes early detection, as I told you, and prevention of problems. As you can see, this statistical process control, in case of process control or product control, we always are measuring the quality of the products before it is produced or before it is being dispatched. So of course it can actually predetermine or can actually forecast the problems, and they can take the preventions to solve these problems. Also, it reduces the waste. It reduces the waste. Over the top, it can lead to a reduction in the time. It can lead to a reduction in time. That is, it is very time saving, reduction in time. Also, it makes it less likely the finished project will need to be reworked or scrapped. So once you conduct SPC, you don't need to rework on your finished project. Now I will be coming to your much awaited topic, that is control charts. I told to talk about control charts in details later the discussion. So now I will be talking about control charts. Before I enter in control charts, I will be talking about a few basic concepts that are needed to study control charts. First of all, what is a control chart? It is actually a graphic device which is used for detecting variations in the production process or the permissible limits of variation. So it is nothing but a graphic chart, which is used for detecting the variation in the production process also it helps in determining the permissible limits, of variation. Now, a very few important parts of this graphic chart or control charts are: one is central line, second one is upper control limit, then there is lower control limit, so what is central line? Central line or CL so as you can see from the name, it is the middle line of the control chart and it indicates the grand average of the sample data. So it is the middle line of control chart and it indicates grand average of the sample data. Let me add a page. Now UCL, that is upper control limit. Upper control limit is the upper line of the control chart. It is the upper line of control chart and it is usually obtained by adding the 3 sigma to the process average. This line indicates the maximum permissible limit of the variation in the process. Indicates maximum permissible limit of variation in process. Denoted by mean plus 3 sigma. Now the next topic is lower control limit, that is LCL. LCL is actually the lower line of the control chart, lower line of control chart obtained by subtracting 3 sigma from the process average. 3 sigma from process average denoted by mean minus 3 sigma, and it actually indicates the minimum permissible limit, of variation in process. Well, this is it for this video. I'll be discussing the control charts and more of its characteristics in the next videos in much more detail. You can keep checking our channel and stay tuned for more videos. You will be given more information about the ISS exams. You can also find solved papers on ISS exams. Well, thank you for watching the video. Stay tuned for more.